Okay, so welcome to this online training for students. Today is the 5th part of our online training series Rfem 6 for students. Today we cover the topic concrete structures, concrete design. So I can say to you, okay, this will be very interesting for you and you will learn definitely some new things about concrete structures. To me, my name is Daniel. I am responsible here as CEO for the management part here at Dlubal. Next to that, also for sales and marketing. And I will be also the presenter for the first part of this training. With me also today is Juliane. Juliane, if you want to introduce yourself, please. You are muted, Juliane.
Sorry, thanks. Hi, my name is Juliane. I'm working for the Dlubal team in the customer support on the one hand, which means customers can contact us per email or call, and they ask about the program, or they have questions according the modeling process. How can they model what they want to model? And we give them support finding the solution. And on the other hand, I'm supporting the developers team. And there we work about improvements for the program, testing it and bringing it forward. Yeah, this is it from my side. I can give the word back to you, Daniel.
Okay, thank you, Juliane. Juliane will be the second voice today. She will do the second part of this training. And yeah, now we can go ahead. I will close my webcam because then you can see more of the screen. So for those who are attending the webinar or the training for the first time, just a few words about our platform GoToWebinar. So here you have your control panel. You can show or hide this panel. You can adjust your audio settings. For instance, when you can't hear us, just adjust here these settings. And whenever you have questions, just leave us a message and we are glad to help you as fast and as good as possible. Good, so our training series, 6 parts. Today, the 5th part, the concrete design. And yeah, what can you expect from today? So first of all, we start with an introductory example. We will model together a concrete beam with a cantilever. And then I will forward to Juliane and she will show you how to design our concrete slab. So let's jump right into it. No theory, only modeling in Rfem 6. So I will open this example and I will create a new model. So for this case, I think it's familiar for you. I'll go here to File or click here on New Model. And now I create here in this dialog a new model with the name concrete beam. Yeah, I will leave it here as 3D type of model and everything else is set it. And now for me, it's important to activate the add-on concrete design. So here we go to the design add-ons, activate concrete design, because then we get additional design properties for our concrete beams or concrete slabs. So I have to activate this. When I have activated this, I go here to the 3rd tab, Standards. And here in the Standards, I see here different chapters like for the design, standard group, load results, and also load case classification. And here I want to design it according to the European or to the Eurocode, with this national annex of the Europe. Okay, I will leave it like that and just click on OK. And a new window opens. And as you can see here on the left side, I have here already some materials and sections and thickness. So, and they are remembered from the last project from the last project I did. So I will delete them in order to create all these 3 things by new, just to show you how to do it. Okay, so you can click here on basic objects with the right click and say, okay, delete all basic objects. And now we can create it from scratch. Okay, so before we do this, I would like to know from you if you have already some, if you have already some skills in concrete design with structural analysis programs, just to show me or give me a kind of status about your knowledge regarding your concrete design skills. So I have prepared a poll, which I will start right now. And please answer me these questions in order to give me a feedback about your knowledge. Okay. Now, most of you have voted. I close this, share the results, and yeah, so the most of you have already designed concrete structures in a structure analysis program. I hope it was Rfem 6 or Rfem 5. For those who doesn't have this experience, no, that doesn't matter. You'll learn it today. Okay. So again, back to Rfem. So here on the left side in the data navigator, I will create 2 materials because for concrete structures, we need 2 materials. We need 1 concrete and 1 material for the reinforcing steel. So I go here to a new material. And now one of the biggest advantages here in Rfem 6 is that I can search for a material via this text box here. And I just enter here C3037. So I am from Germany. I will design it according to the Eurocode because this is the only standard I know. And this is the reason why I choose here this one. So, okay, the next one is I create a new material again. And here I choose here I go to the material library and looking for the material type reinforcing steel. So I can here filter according to different material types, and the one I'm looking for is the reinforcing steel, and in this case reinforcing steel B. And yeah, here I see different things. So this B 500 or 550, this is for the yield strength. A and B, this is for the ductility class. A is the normal one, B is the high ductility, and S is for the normal member reinforcing steel, and M for the mesh reinforcement. So in this case, I choose here this B500 SA. I click OK. And yeah, this was it. I click OK again. And the next one is to create a new section. So because we will model and design a concrete beam, I click here on section, click here on new section. And therefore I have to choose here this rectangle massive cross section, or when you don't have here this, just go here to the cross section library and choose here this massive rectangle. Then I can give here the geometry. I have a width of 300 millimeters and a height of 450 millimeters. Then I can see also the section values according to this geometry and also the stress points. And if I want, I can also show me the unit stresses. In concrete design, not so important, but yeah, we have implemented also this here. Okay, that's everything. I click on OK. Thicknesses, I don't do it right now. This will be more the part of Juliane because she will show you what are thicknesses. Thicknesses are similar to the cross-section things for members. Yeah, this is the similar thing. thicknesses you need for surfaces and sections for members. Okay, so now we will model it together. We will model the beam. I go here to the symbol bar, click here on new single member, and now I choose here the right section because I have only one section. This is everything, so I click here on OK and draw this member 8 meters long. I can do this via the grid points or also by inserting here member length like 8 meters. And as you can already see, we have here already the provided reinforcement based on some general information about this concrete beam. We can modify it afterwards, of course. What I want to do right now is that we divide here this member internally. So the member remains as one member, but we will add him in an internal node. So double click on the member, activate the option nodes on member. And there I want to switch between an absolute distance. I say here, okay, from start, please 6 meters away. And here you should create a new node. I click on OK. And you see here this blue node, and double click on this node. He has the node type on member. So, and this is a really nice opportunity or possibility, giving here this node and giving this node the option to be part of this member and not to divide this. Okay, so the next thing, supports, node support. So I create here a new nodal support. Also, I want to activate the rotational around the global X axis in order to prevent torsion, and then a roller support along the X axis. This is this one. I click on OK. Perfect. Okay. Yeah, so much to the modeling. Now let's go to the load cases. I go here to the symbol bar, edit active load case. And here I have the self-weight. This is okay for me. Now I want also to consider an imposed load case. In this case, we have two fields, one field and the second field. So I create the first one. This is imposed load field 1. Now I copy it and click here field 2. Now I choose here the load case 1 because then I jump to the load case 1 where I set some loadings. Okay, so the whole concrete beam has a member load of 10 kilonewton per meter. So I click here this member load, insert here a value of 10 kilonewton per meter. And now the biggest advantage now here in Rfem 6 is that I can stay here in this dialog, just select the same member, and then afterwards just change the load case and add the parameters like the load magnitude again to the members. And I don't have to leave this window. This is a real good advantage. So I click here this member. I say apply and next. Now I change the load case, and now I have to change the load distribution because we only want to apply the load on the left field. So I say trapezoidal. Here in this case, I have 20 kilonewton per meter, 20 kilonewton per meter on the right side, and the load distance goes from 0 to 6 meters. I say in this member, please apply and next. Now I change the field and say from 6 to 8. I can insert here 1, say okay. Now let's do a check. Okay, seems good. So back to the load cases, maybe a few words to that. So we have here this load case classifications according to this European standard, so according to the Eurocode, and we have also here this combination wizard, and this combination wizard helps me to combine different load cases with each other, considering the partial factors. Now we see it here also, we have here these different actions, and depending on these actions, it will also get me the right factors for combining it, and according to the design situations, it will combine it. So you can also take a closer look about the combination rules, like here. Yeah, and for our simple example, we don't need so much design situations. So these two serviceability design situations, like characteristic and frequent, I will delete. I only need here this ultimate limit state and this serviceability design situation, quasi-permanent. And let's go to the action combinations. And here, these are the factors I need for my load combination. Okay, good. This is everything. Now click on OK. And now I need to define my design properties for my concrete design. So where can I do this? Double click on the member of this concrete member. And now you see here the design properties. And when I have activated the add-on in the base data concrete design, then this option will be activated automatically. I can also deactivate this, and now you see, okay, all these registers here in the upper menu will disappear when I activate it. The other tabs are there. So what do we do now is that we go here these tabs through. What we don't need is the concrete effective length for any stability proofs, but this is a classical bending member, so I can neglect this. So I go here to the concrete cover. Yeah, the concrete cover is pretty clear. So you have different exposition classes in order to determine the concrete durability. So you can open here this. Now it's for all section sites. You can modify it. You see here this different exposure classes. Sorry, exposition classes is was the wrong word. Exposure classes. Here you have this XC1 up to XC4 due to corrosion induced by carbonation, or also here when I want to consider exposure classes for concrete, freeze, thaw attack, and so on. And through these exposure classes, the minimum concrete cover is determined. So for our simple example, this simple XC1 is okay. I say okay again, and this minimum concrete cover is determined from the outer edge from the concrete rectangle to the outer edge of my stirrup reinforcement. And these are 20 millimeters, and they are determined by the exposure classes. I can also say a user-defined concrete cover, or when I want to consider it for each site differently, I can activate here also this different at section sites. Okay, so much to the concrete cover. Now let's go to the shear reinforcement. So we can here adjust some stirrups. We have the possibility to consider different stirrup types, like two-latched or four-latched, something like that. So if we get a lot of shear forces, then it's possible to do this with four-latched stirrups. And in this case, I change here the bar diameter from 10 to 8 millimeters. And also the distance from 0.3 to 0.50 millimeters. Okay, so much to that. You see also here on the left side, you can add here more shear reinforcement spans. then you can separate the distances into several fields within this member. Okay, now let's go to longitudinal reinforcement. Here I have also some possibilities regarding the rebar type, symmetrical, unsymmetrical, and in this case I choose here unsymmetrical. And okay, unsymmetrical means that the upper, so the top side and the bottom sides are different. So for the top side I choose here 2 and change here the diameter from 20 to 12. And also I want to activate here a lateral sidebar with 10 millimeters. And for my downside, so for my bottom side, I choose here 60 millimeters. Okay, so much to that. And yeah, you can see also here different anchorage types and so on. So if you define this, this will be also considered in the design proof. But for this simple example, we don't need it. Now, design configuration, here you find more information about the different design parameters, like Excel for so design parameters regarding considering internal forces for concrete design and so much more. Also the reduction of internal forces in Z direction. Here in this case, I activate the limited moment redistribution of the supporting moments. And also this one, the reduction of the moments for the ones at the face, of monolithic support according to this standard, to this capital. So yeah, here you can define also several other options for the design of concrete. These are the information given by the standards. Okay, and the same also for the serviceability, but yeah, this is some more information. So now the last tab is the design supports and deflection. So when you want to design the deflections, so really the deformation proof, then you have defined here different design supports. We do this here for this simple beam. So in this case, I create here a new one with a support width of 360 millimeters, and it's no inner support, only support in Z-axis. And yeah, that's everything. And now I create a new one also with 360 millimeters. It has a monolithic connection, and the ratio of moment is in this case 0.9, and I don't need to consider any y-axis. I click on OK. Now I have to assign it to the right nodes. So that is on member start, this is correct. And now here to the middle, the second one. Oh, sorry. No, this is not correct. Now this is correct. I say OK. And now I can calculate it. Let's say concrete design. And now you see, okay, how the whole situations are calculated. Also for the serviceability. And what I don't need is to design for the ultimate limit state. I only am interested in the results of my ultimate limit state. So I calculate the concrete design again. And now I see here the different design ratios or members, and I see, okay, here detailing of members and also the ultimate limit state, section resistance is not fulfilled. So what can I do? I need to strengthen my reinforcement. Maybe here some words to this reinforcement. Here on the left side, I see the results navigator, and here I have the possibility to show me different results. So like the reinforcement. So I see here the required reinforcement for the, maybe I deactivate the design check. I can show me the required reinforcement for the top and the bottom. For the top and the bottom reinforcement, I can show me also the stirrups and also the provided reinforcement for the bottom side. and I can deactivate here the rendering of the reinforcement by going here to the display navigator, go here to types of concrete design and deactivate it. And now I can see here the result a little bit better. So I see, okay, my provided reinforcement is lower than the required reinforcement. So I need to add some more rebars. And also, in order to calculate me here the difference, what I need, so the not covered reinforcement, I can also show me it. Okay, so what can I do? Go back to the concrete beam, go here to the shear reinforcement. Now we want to add more rebars for some places. So I go here and copy it. And now I want to cover it for different fields. So you see, okay, the start and end goes from 0 to 4. I say, okay, this should go to 6. And this one should go from, oh, sorry. This should go from to 5, sorry. This should go from 5 to 7 with distance of 1.1 meter, sorry, 0.1 meter. And the other one should go from 7 to 8 meters. And the longitudinal reinforcement, let's make it quite easy. So what can I do here is just increase the diameter here for my top side and add here a diameter for the bottom side to 20 with 2 bars more. And it looks like that. I can show me also this reinforcement plan by clicking at this icon, and I see it here like that. Then I click OK. I design it again. And now I see here my fulfilled example, my fulfilled design check ratios. And by clicking on one of this, like this one, you see also here this design check. Also, you can switch here to different design checks. So in this case, we have here the design check according to this standard shear resistance, reinforcement shear capacity. And when you are at study and you want to compare your results with the results of our program, then you have here an overview of how the program did this. Okay, so much to the beam design. Before I forward to Juliane, I have a poll for you just to summarize the example. Okay, the most of you have voted. I close this and I share the results. And yeah, the most of you have voted the right answer. So when you want to perform a real deformation check, then it's important to define the design supports for members. Okay, and this was it from my part. And now, Juliane, I forward the presentation to you.
Okay, then I will go on.
I will make you as moderator, as presenter. So
I can share my screen. I hope you all can see my screen now. Before we can go into the program, I would like to give you a short overview about the object of our analysis. We are going to analyze this concrete slab, this reinforced concrete slab, and do the design for it. The slab is based on walls and columns, and we also have here L-beams at the border of the slab in order to make it more stiff there. And the parts of the structure will be of the material C3037, and the wall and the columns will have the concrete to, C2530, and we will have the self-weight as a load and apply also a live load of 3 kilonewton per meter square. And then we again will do the load combinations, and we will let the program generate it for us. And after that, we will do the analysis and use the results for the concrete design. So this is it so far as a preparation. Now we can go into the program and start modeling. I will again open a new model with this icon here, and we get into the base data dialog. I enter the name, it will be a slab, and it's made of reinforced concrete. So as an additional information, I give it here. And yeah, the other settings we don't need to change. Again, we have to activate our design add-on, the concrete design, and in the standards, I also want to keep the National Annex SEN as Daniel did. Okay, so we can agree and say, okay, this is okay. So now an empty model is prepared for us, and we can start modeling. And I would like to use a guide object with you. I would like to use a background layer. We have a drawing from the architect in an DXF format, and we can use it as an orientation to create our Rfem 6 model. Therefore, I have to get the file from my folder where I put it, and I have here the ground plan for our slab. And we have here the preview. We can check it, and in looking at this, I can see that I need to rotate it with an angle of 180 degrees around the y-axis, and I can see, and now in my preview I see this is what I wanted. I want the ground plan to be positioned like this as a background layer. So I can say okay, and I have it in my model now. So all these lines are DXF objects. Now I need to create my objects that I can use for the Rfem 6 model and the analysis. Therefore, at first I want to start with the lines. I will create the boundary lines for the slab. We have one here, and we have one here. If you want to end any process you are in, you can do it with right click, and you can leave the thing you are doing currently. So now I want to copy this line. I select it therefore, and I press Control, and I can have a click on the line and then draw it to here. Okay, and I will do the same with this line. I press Control and I can put it here, and I finished my boundary lines. Then also I want to have lines here, because the lines we see, they are DXF objects, and I need to have parts of the structure modeled with Rfem 6 objects. Okay, so what I also need is nodes. I need nodes for these places where the supports or the columns are placed at. So I put some nodes. I will do it here. And I can see that I need an X value of 2.40, but I cannot reach here correctly. So I put this node here, and I put another one here. And now I can edit this node. I double clicked on it, and I can see the coordinates here. And as we saw, I need 2.40. And I can say okay, and it goes there. And here I checked it, I need 7.40, and then it will be at the right place. Okay, so now I prepared the nodes on that line, and I need them actually in this line, and this axis as well. So I have to select them. I want to copy them. with pressing Control, I can again and again add the selection. Okay, now I want to use drag and drop. I again press Control and I can take the note, and copies are created, and I can put them at the place where I want them. Here's the end of the wall, and it fits. And now I can see the newly created notes again are selected, so I can go on with them. And now I want to show you this menu. I did a right click on the note. I also can use this move and copy option. I say I want to create a copy, and I have to give the displacement vector here. And now I want a vector like this, and I can say apply, and I can see the program copied it, and I can repeat this and do another copy into this row and say OK. And now I see I have all the nodes that I need for modeling. Now there is one thing I want to do. I want to divide this line into parts, because when I want to define the surface, I want the surface to be within these lines. So I shouldn't have a line that is not divided. So in order to do this, I select all my lines, and I can use this option here. And now every line is divided at the nodes or lines that it's connected with. Okay, now I prepared the first step of the geometry. Now I also want to use the data navigator and work from top to bottom like this. At first we want to check the materials. Have a look at the list. I also have the first two materials from my last model, and I want to use them with you. It's the C30, 37, and also the 2530 that we need. One material is missing, our reinforcement steel. So we go to the library and choose for European Union the steel, and I want to have this. What I remembered now is here I will check this. We will have a look here. No, it's okay. I checked the standard because it's important that the standard fits to the standard you selected at the beginning. But it fits. I have the right standard. Okay, so now my material list is fine. I can say OK and leave this dialog. Then we can go to sections, and I also want to delete it so that we can create it together. We create a new section, and it's right. It's going to be the section of our L-beam, and it has the same material like the slab. And here we have provided cross-section types for beams, and we are right, we want to use the rectangular. We can go to this dialog for entering the dimensions. Now I will show you. We want to create our L-beam, so we have 24 centimeter and 45 centimeter in the height, and we can enter this 24 centimeter and 45 centimeters, so 450 millimeters. Okay, then I have my section prepared for the L-beam, and I also will prepare the thickness that I need for the surface. As Daniel said, for beams, for 1D members, you need 2D cross sections, and for our surface, which is a 2D member, we need only to define the third dimension, the thickness for it. So we can go here. We have the dialog for the thickness. It shall be a uniform thickness. This is right. It's the material for the slab. It's also right, but it has to be 24 centimeters, so 240 millimeters. Okay, and I say okay. Now I prepared my cross sections. Then I can go on with creating the surface. I could do this from here, but I want to use an option we can reach here more easy. We can define a surface via the selection of boundary lines, and this is what I want to use now. Here we see the dialog for the surface. Here we can enter all the things, all the options the surface has, all the settings and input the surface needs. And it shall be a stiffness type standard. This is good. We have the right thickness and the right material. And as we can see, because we applied the concrete design add-on, we also have design properties. Those I want to have a look with you at later. Okay, so we can agree. And now the program, if we go into our working window, the program tells us what to do. You can read it here. When I go back with my mouse into the field, we can see that now we are supposed to select the lines for creating the surface. So I just select the lines, and Rfem 6 created the slab, the surface. Okay, I can leave this. I do a right click, and now I'm free again. So now I want to create the L-beams. The L-beams are positioned everywhere where no wall is positioned at the border lines. So I select all the lines that will get or receive an L-beam between the columns. Here's going to be a wall, so I go on here. We have a wall here. Here shall be an L-beam, and here are going to be walls. So my lines are selected. I can do a right click on the line and say edit lines. And I come into the dialog for editing lines. And here I have the option to say that for these lines, there shall be a member along these lines. And then we activate it. And when we activate it, we get into the dialog for defining the member. And here we can see the member type we have to set in the main window. And we have a special member type for L-beams or T-beams. It's called RIB in Rfem 6, and I select it. Here you can see we want this type of member. And with entering RIB, we see that a new register opened, and we have to look at it. Here you can decide whether your beam shall be below or above or maybe centric in the surface. We choose the one it shall be positioned below. Okay, then we can go on. We go into section. We have to define the section for the member, for the part below of the surface. And Rfem 6 automatically applied the first cross section that we defined. So this is the right one. This is the one we defined, and the material is right as well. We can say, okay. What I want to do is I want to switch off the design properties, because we today our main object, our focus is on the slab, and we don't want to analyze the design for the RIB as well. So I can switch off the design properties. The program then knows that these RIBs shall not be considered in the concrete design. And I say okay and leave this dialog. And now all these lines have these members that we defined applied, and we can see it in the main window. Yeah, now we finished actually the structure. As I said, we want to have the design for the slab. So we are actually not interested in the inner forces or stresses or strains in the walls or in the columns. That's why we don't need to model them. We have special type of supports that I want to show you. At first, we therefore go into the types for nodes. Here we can find nodal supports. And I want to create a new one. We have in Rfem 6 the option to give a support that contains the stiffness via fictitious column. This means I can activate it, and then a new register is opened and we have a look at it. Here we can enter the dimensions and the material of the column, and Rfem 6 from these informations calculates the stiffness the column has. So we can model a support that behaves from a point of stiffness like a column behaves, but we don't need to model the column, and we don't get inner forces or something. We are not interested in it. So I can choose here elastic nodal support. This is what I want to have. Our column has dimension 40 centimeter and 40 centimeter in the other directions, and it has a height of 2.25 meter. Yes, and it is hinged at base and head, and I have to take care. I should change the material. We have less stiff material here, and this is the stiffness of the spring the program calculates from this column dimensions and material. And now we can apply this at the nodes where this column is positioned. Here, okay. And now again, I can stay in the, I can say apply, and I can stay in this dialog as I have some more columns, these, and I can go on with defining them. I also want to delete those nodal supports as I don't need them. And now I can create a copy of the last support that we did together, because it has, it's again a stiffness via fictitious column. And what is changing is the dimensions. It's going to be 1 meter in the width direction and 2.25. Let's check it. Yes, 2.20. It fits 25 centimeter in the height. The height of the column is 3.25 meter. This is right. And the other settings we can keep. It's right from the copy. Okay, and I can apply these columns here and say apply again. And I can create a last copy. Here I change only the width and height. And I can apply this or assign this to this node. Okay, now I have all my different type of columns defined, or the supports of them. And we can see it here. I can also, here I can change the display of the model. I can say that I want to see a wireframe model. Then we can see, for example, now the supports more clear. And if you think the supports are a bit small, you can do a right click on them and make them bigger. Then it's more easy to see them and check whether everywhere where one is supposed to be also a support is. Okay, we have the same tool for walls. We can consider the walls as line supports. So we can now go into the folder types for lines. And here we have the line supports and can create a new line support. And here I have the stiffness via fictitious wall. And I can only reach this option if I activate local XYZ coordinate system. Now you can see it's possible to activate it, and we again have to go here and define geometry and material. The wall has a thickness of 24 centimeter and again a height of 3 meters 25. The material also shall be material number 2. And now the program calculated the stiffness that resembles the wall. The X direction is the direction along the length of the line. So we have a stiffness in this direction, and the Z direction is the vertical direction. We have also this spring. Okay, now we can assign it to the lines where we have actually walls, and they are these. And here's another one, and I think it's completed. I can say okay, and we are now fine. Now we have all the supports that we have from the walls and lines. I again go to the transparent model, and I can see our structure. We have finished the structure now. What we need is the loads. So we can close here the settings for the structure and go to the load part. At first we enter this load cases and combinations dialog. Yeah, and again we activated the combination wizard as you saw with Daniel. Now we can go to load cases. We have as a default load case, always load case 1 is a self-weight load case. You can also see here the self-weight is active and it's a permanent load case. And we want to create another load case. This is the live load case. And here we don't want the self-weight to be active, and it has to be an imposed load case. It's important that you take care about defining the right action category, because we will do the action combinations. The combination wizard is going to do them, to generate them for us, but he can only do it right if you set the right action category. So we have a permanent load case and an imposed load case. Okay, then we can have a look at this. Here you can see which type of action categories you have in your model. This helps when you have a lot of load cases in bigger models to keep an overview. Then we can go to design situations. Yeah, we have those prepared for the concrete design. And I want to show you also the combination wizard. Here you can do settings for how the combination wizard shall combine or create the load combinations. And I want to use the geometrically linear analysis. I activated it here, and we don't need to consider imperfection cases. So I can set it okay. And yeah, then we can go on. We can check the action combinations and see also the load combinations that are generated from that. So now we finished that part. It's okay. We have the load cases and the combinations. Now they are prepared and we need to fill them with loads. We have this folder loads here, and we can see our load cases, but they need to be filled. We need to say what kind of load has to be contained in live load. In self-weight, we have a load because we said self-weight shall be active. This means the program calculates from the cross sections and the specific weight of the material, the self-weight of the structure. So we can have a look at this. I switched from data navigator to navigator display, and here we have the option to activate loads, and within the loads we can activate the self-weight. And then you can see for load case self-weight what the program calculated for the construction parts. So we can see load case 1 has a load. Now we can go to load case 2 and we see we don't have a load yet. So we create one. We create a surface load with right click and say new surface load, and it's supposed to be 3 kilonewton per meter square, and we apply it to surface number 1, and it's okay. And we can see now also we have a load in our live load case. So I want to save it once. It's good to save from time to time. Yes, this is it. Now we prepared our model. We have the structure, we have the loads, we have the geometric boundary conditions. Now our model would be ready to do the finite element analysis. We could calculate the stresses and strains, the inner forces and displacements for this structure. What we want to do as well is we want to do the concrete design. So we have to define the properties for the concrete design. Therefore, I just double click on the surface and we can see all the design properties that I can set for this surface. Now I want to have a look at them with you. Here we have the concrete cover. I think Daniel said a lot about it. It's fine. We can go on, I think. We have for the surface the option to set in which direction the first reinforcement direction has to be. For us, it's now X, and the second one is in Y direction. Then it's okay for us. We can go on. Now we have the register for surface reinforcement, and we see that our list is empty. So we have to define a surface reinforcement, and we can do this via clicking here. And then we have the dialog for defining new surface reinforcements. And here we have a surface reinforcement of the type on surface. This means the surface that is assigned will get this reinforcement everywhere. So independent of the geometry of the surface, all the surface will be covered with this reinforcement you define in here. And I want to, at first for the top, define a reinforcement of 8 millimeters with a distance of 15 centimeter, and in the transverse direction also 8 millimeters with the same distance. The program tells you how much centimeter square per meter you put, and yeah, it's fine for me. I say apply, and I copy this reinforcement because I just put it at the top. I want to create the same at the bottom for now. I generated, I entered two different surface reinforcements for top and bottom, because I can imagine that maybe later I will change one of them. They don't need to be the same. So I can say okay, and now my surface has a reinforcement. Then we again here have design configurations. We can have a short look into them. With Daniel, you saw those. We can have a look at the surfaces. This is something you should have a look at. For now, for us, we keep the default settings, but you should know what is decided in here. For example, now we have minimum longitudinal and maximum longitudinal reinforcement defined for plates or for slabs, which is fine for us. But if you want to make the design for a wall, you should apply design configurations for walls and this setting for walls. Yes, but for us, for now, it's okay. I can say okay and keep the default setting. We have this something similar for the serviceability state. Yeah, this is what I wanted to have a look at with you for now. We defined our surface reinforcement, and then I close it. And now we also can see it in our graphics. Here I can switch off the loads. So now I can see that my reinforcement is contained in my surface. So this is it for us. We can now start the analysis, and I want to do it from here. We can here choose the concrete design in the table, and here we have our input data. And for now with you, I want to just do the ultimate limit state analysis. So I switch off those. And also in the objects to design, I want to say that I only want to solve the surface. Actually, the program sees that the ribs, which are members, cannot be calculated. They are invalid because they don't have a reinforcement, so they wouldn't be contained in any way. And also I switch off the nodes for punching. So we have our surface. Yeah, and we did these settings. Now we can start the concrete design from here. And I started. And the program knows when we want to do the concrete design, it also calculates the design situation that is needed for the concrete design. And it also calculates the load combinations that are contained in that design situation. So it calculates everything that is needed for the design. Yes, and here we have our result. And I want to show you, as I said, for the concrete design, we said that we want to solve the ultimate limit state, which uses design situation 1, and design situation 1 contains all the ultimate limit state load combinations. So if we check one of them, we see we also have results for those. And what I want to show you also is here we have our navigator results. Here we can decide about the view on results, and we can set here also static analysis. Here we have our results of the finite element analysis. I will switch off the mesh, we don't need it. Here we have global deformations, internal forces, stresses and strains. And these results are used in the concrete design. So now we can go to the concrete design. I want to now switch off that I can see the reinforcement. It disturbs the view on the results. I can do all these settings for the display and the navigator for display. And I can here in the model, in folder types for concrete design or in the point types for concrete design, I can switch off I can switch them off so I don't see any reinforcement, and I can look on it from in that direction. So now we have our first design results, and at first I want to show you this. This is the overview for the design, and it generally at the beginning doesn't look very friendly, as here all the problem points are listed. You see a lot of red at the beginning, but this will change. I can here say that I don't want to have this overview. I want to see now, for example, design ratios on surfaces. And if you have more surface, you can also set that you want to have it separately for each surface. But we have only one now, so this list is fine for us. Here we can set which design checks we want to see, which design check types. And now we have the ultimate limit state active, and here are also detailing proofs active, and I don't want to have a look at them now. We only want to at first check the ultimate limit state, which is also the much more important thing. Okay, so now we can have a look at the navigator results a little bit more in detail. We have two main things that we can look at. We can look at the design checks or at the reinforcement. At first, I want to have a look with you at the design checks for surfaces. And we now are looking at this one, UL0101, which is for longitudinal reinforcement into first direction on the top side of the surface. And this is something we can imagine and expect. We have the most high ratios around the supports. So we have here at the top of the surface the tension around the supports or above the supports. And the same is in the second reinforcement direction, we can see. And now we can guess what will happen if we look at the bottom side of the surface. Here we can see that we have the most tension and the highest ratio for these checks in the fields of the surface, as there is the tension at the bottom. Yeah. Okay, these were the results of the design checks. And now we can have a look at the reinforcement the program calculated with doing these design checks. We can see which reinforcement is required from all these design checks the program did. And we can have a look at the top. Here we can see which centimeter square per meter, how much is needed for top in direction 1 and direction 2, and also for the bottom of the surface. What we also can see is which reinforcement we provided. We put reinforcement in there, and here we can see it. It's 3.35. We put this in each direction at the bottom and at the top. And the program also gives an overview about the not covered reinforcement. So we have put some, we provide reinforcement, and it compares the provided and the required reinforcement and shows where our provided reinforcement is not enough. And there we can see at the top of the surface, in this area, we don't have enough reinforcement in this direction and in the second direction like this, and here in the fields. So the first step that I want to go with you is changing the bottom surface reinforcement. Therefore, I go back to the data navigator, and yeah, before I went to the design properties by clicking on the surface. Now I want to show you that all these concrete design settings you also can find in the data navigator. We have here the types for concrete design, and here all our reinforcements in the whole model. And here we have the configurations for the concrete design. But now we want to change our reinforcement. The second reinforcement, as we can see, is for the bottom. I double click on it and I can edit it. Now I want to put the diameter 1 centimeter at the bottom of the surface. I say OK, and the program gives a warning because our design results will be deleted because I changed the reinforcement. It's OK for us, and I can recalculate the concrete design. So, and now we can have a look into the not covered reinforcement, and we can see now I put enough. We don't have any problems at the bottom of the surface. Now we want to care about the top. I didn't change something yet in the top. And what you always can do is, if you go here on the design ratios, you can have a look at these positions where the ratio is too high, like Daniel showed. You can double click on the design check type and you compare it with some analytical solutions or some hand calculations. You can check everything that enters into the design check for the concrete design, and you can follow the standards, the equations from the standards, as we always write from where this equation comes, and you can go there and compare it, and it's really comfortable to follow what is our program doing in this concrete design. You can find all these values that you need, everything that you did. Each formula is listed here. Yes, and when you check this and you agree that there is more reinforcement needed, you also can put some local additional reinforcement, and we will do this now for these supports places. Therefore, we go back to the data navigator again, and I can do a right click on surface reinforcement and say that I want to create a new surface reinforcement. And here we have the type, and now I don't want to put reinforcement on the whole surface. I want to use a free rectangular reinforcement. The material is automatically entered here. What I want to do is I want to apply a reinforcement only on the top, as I have the tension on the top, and I want to have it in both directions, and I will put 16 millimeters with a distance of 10 centimeter in both directions. So here you can set the dimension and the material for the reinforcement, and here you have to enter the position of your free rectangular layout of the surface. You also can enter which reinforcement direction shall be the first, but we can keep the default settings. What I want to do is I want to say the position, I want to tell the position, and I prefer this setting now for our problem. Here I can enter the center. I can pick it on the working window, and I can enter the dimensions, and I want to have 3 in this and 4 in this. Okay, and it's going to be assigned to surface number 1. I say okay. It comes the warning again, and I don't want to see results now. And I also will the wireframe view. I want to show you the reinforcement. Therefore, I again activate the types for concrete design. And here now we can see we have the surface reinforcement still, and we have some additional reinforcement there. I can also switch off the surface reinforcement of type on surface, and then I can see only my additional. I didn't want to have it like this. I want to have it with 4 meters and 3 meters. I want to have it like this. Okay. And now I want to copy this. And as I see the distance, I want to have at all supports this additional reinforcement. So I want to copy it here and here. And the distance is the same. So I can use this thing. I can use the move and copy and say create copy, but not only one. I want to have 3 copies now. And I can say tell the displacement vector it has to be a distance like this. And I can say OK. And now my 3 copies are directly generated. And I want to also have a copy up to here. I need here some additional and also at the corners. So I do, yeah, now it's only 1 because I don't want to have more in the next row. I give the distance. It's the same like from here. No, I cannot do it like this. The displacement vector has to be from here to here. Okay. And also I want to put here some additional reinforcement. It's due to the change of stiffness. We have here the supports, and here's no support. Here's the L-beam, and again here comes supports. We also have some singularities here. So I also put some I put a copy there. Yeah. Okay, so this is it. Now we can again calculate it and check the results. Yeah. I again switch off the reinforcement, and we will go into the design checks and check the top. I have to switch on the design checks, can switch off the reinforcement, and now we see the first direction on top, and also the second direction at the top. And yeah, we see that we have at very small places some higher values, but mainly we fulfilled the requirements of the standard with our additional reinforcements. So I want to now keep this design. I only want to show you a last thing. You can also change the type of display. When you want to print it, for example, it's not very comfortable if you have so much color in it. You can, here in the navigator results at the bottom, you can change the type of display. For example, you can change it to ISO lines, and you can say that you want to see the result values. Then you have the values for each line, and it's more easy to print into your report or something. And we have another option which is comfortable for this. You can show values on surfaces. Now it's a bit crowded, so we close this. It showed so many values because it shows the values dependent on the grid within this setting. And the grid we can change in the surface here. We can say we want to have a grid with bigger distances, so there will be less values shown. And we can shortly calculate them. And then we can also use the values on surfaces, which is nice for printing it, for example. Okay, so this is it. This is what I wanted to show you as an introduction into the concrete design for surfaces, for slabs. Yes, I would like to give my word back to you, Daniel. I think we learned a lot.
Perfect,
Okay.
Juliane. Thank you very much for this
you're
presentation. It was very interesting because of the reinforcement and concrete design of slabs. I would share my screen now in order to summarize the whole thing through some polls, just to give you a kind of finalization of this online training. So yeah, please answer me that poll. So which components can be modeled with the member type RIP? Several answers can be possible. Okay, so most of you have voted. I close this, share the results. So all 3 questions are correct. So with the member type RIP, you can design downstand, but also upstand beams and T-beams. When you want to consider the integration width, you have to use and consider the member type RIP. So the next part is this one. So maybe Juliane, you can say more to the results of this question.
Yes, yes is the right, no is the right answer, sorry. Yeah, the finite element analysis doesn't consider the reinforcement. The static analysis that is done at first doesn't use the reinforcement, so the results are not dependent of the definition. The reinforcement is used for the design calculation, which is done with the results of the structural analysis, with the stresses and strains, and yeah, there the reinforcement is used.
Thank you.
You're welcome.
Okay, so now last words from my side. I just want to show you what is new on our website. We have published a new blog about our company. This blog is mainly for some insights about our company, like where have we been with some of our colleagues, so some conferences or some booths and so on. But we have also some interviews with some employees with our team. So for this example, Jaroslav Brosch is one of our developers, and one of our colleagues did an interview with him, and this could give you a kind of how we work at Dlubal. Just we share some knowledge, we share some information about our business, and yeah, maybe it's also interesting for you, or also some podcast episodes where we now do the text for our blog and so on. Yeah, so take a short look to our blog. It's very interesting. Maybe you are also interested in 3D printing or the job as support engineer. You can take a quick look to the interview. So to put it in a nutshell, I want to say thank you very much for your attention, and I hope also that we will see us the next time when we do the timber designs or the last online training for students. And yeah, so I wish you a nice time, stay healthy, and see you soon. Bye bye.
Bye bye.